Okay. You understand that some maths we just get through yesterday. That's not a basic you need to know. However, as a technician, you don't have to do any calculation. Just try to find how they're working in order to fix the problem. Okay? We just go by the basic. Very, very basic in electronics. I think in next week we will be stuck. Take one with the electronic. Okay? Not learning about any device in the electronic, not the DC anymore. If you go college, you have to learn more. The thing is you have to solve an equation for different circuitry and they go more detailed, just a theory, not really good for the technician at work. Yesterday, we already got talking about resistor. Basically, resistor will be opposite to the current flowing. That means you get a big value of resistor, then the current will be smaller. Okay? And resistor, they can get the color code. You can see on this one here, 1, 2, 3, 4. So they go a first band, they say a first significant digit, a second one, a second digit. Next one will be multiplier, and next one will be tolerant. Now, I can talking about tolerance. If you get a resistor equal 100 ohm, if you want to get a value, you can use in a color code, but the technician will be a meter, DMM, digital multimeter, to measure the value. However, no way you can get exactly 100 ohm. Okay? For any measurement, the measurement of frequency, measurement of voltage, measurement of current, you cannot get exactly the value like the calculation. So that's why they come up with what they call tolerance. Okay? Now, in this one, they say tolerance 10%. So we have to calculate to say 10% of 100 ohm. Okay? So first thing you need to calculate the 10%. 100 times 10. So it just look like 10, right? 10 ohm. So when we get the tolerance of 10 ohm, then we need to get the upper level, upper limit. UL equal 100 plus 10, 110. And a lower limit equal 100 minus 10 equal 90 ohm. So when you measure, you get R equal 95 ohm. Is it okay or not?
It's okay.
It's okay. The thing is they in the range from 90 to 110 ohm. Accepted. However, if you get R equal 75 ohm,
No, it's below 90.
yeah, that's out of limit. So that's not good. So that's okay. And that's not okay. So when you do your homework, the same thing. You cannot exact value like I given to you. However, you can make a choice to the value very close to the value we wanted. That means I already set the tolerance like 5% or 10%. Okay? So you understand the tolerance.
Yes, sir.
That's good. Okay, and now another different type. They call a precision resistor. Only the difference will be this is 4 band and this will be 5 bands. Okay, so the thing is the first one they will be a first digit, second digit, third digit, and this will be a multiply and blue will be tolerant. Now, for general purpose, that means 4 digits. Okay, they already given you the table here. If the brown, then the first number will be 1. The next one, next band, if they get the number 2, that means the second digit, 1, 2. And the next one multiplied by brown, that means multiply by 10 power 1, the 10. That's what you get the value. Okay, and the last one, okay, if you get the color gold, they will be 5%, silver 10%, none. That means you don't have any color, 20%. And this only a different precision. Okay, 5 bands. First digit, second digit, third digit. And that will be multiplier. And that will be a tolerant. Okay. Same thing. So we don't care about that one. Like you see, the color here, first digit, second digit, third digit. Okay. And this one basically, let's see.
Mr. Pham, can you repeat that last part one more time with the digits?
You know, the first one is a first digit, right?
So on the picture, you were showing it, but
Right here. First color.
oh, okay, got it.
First digit. Okay, you can do an example. You can see. Now, in order to understand, try to example number 1. A resistor manufacturer produce carbon composition resistor 100 mega ohm with tolerance plus minus 5%. What will be the color code on the resistor? Okay, 1 mega ohm. The answer will be, the first one will be number 1. The second one, second digit, okay, 0. Violet, that means multiply, okay, and gold. Gold, they're telling you gold 5%. So 1,000, you have to multiply by what number to get 1 mega ohm. 1 mega ohm means 0, 0, 0. Okay. Let's see. How many more 0?
7.
Is it 5 or what? That means they have to multiply by 10 power 5. I try to say violet. Violet will be multiply violet here.
Yeah, should be 7.
That means multiply by 7. Okay, so basically will be multiplied by 7. Okay, and plus minus 5% gold. Okay, so that's why you can get brown is 1. Make sure we get a brown is 1. That's correct. Brown is 1. Okay, and if there's no color, 0 will be a black. Okay, so 1, 0. Okay, third band multiply. We already know multiply is violet. That power 7. Okay, this one. Oh man, that guy, where to go?
Just click on it and hit the delete button.
Delete button.
Or select it first.
They don't want me to select it. See that?
You had it selected.
I think you just have to click on it and then right click and then delete.
Yeah, I want to click it in here. Select here. Okay. Copy, cut. They don't cut it.
Select it. You had it selected and then you moved it from like the lower page. Grab it again and move it back.
But
You got it.
see that we can select that one. Okay. They don't want it. Okay. I don't know what. Let me find. Okay, so we can go into that example. Now, this doesn't matter. The thing is, you never have to do it. Only what you do is you're looking into the register, okay, and try to see what the value. So go ahead and tell me, number A, first, brown, green, yellow, silver. I want the answer. Whoever can get it done telling me. So make sure everyone, when you're looking into the color code, you're able to recognize the value. Even you have to use in the table. I just want to do on the number A. What the value number A?
$150 kilo ohms, plus or minus.
Just a minute. 50 kilo ohm, right?
Plus or minus 10%.
I believe it's not the right answer.
So brown, 5 times.
Okay, brown is what number?
1,
1,
1. Green,
5,
5,
5. Yellow, multiply by
4, 10 to the 4th.
you get 1, okay. You get 5, okay. But yellow multiply by what number?
Ten to the 4th.
Yellow,
10.
4, right?
Yeah.
4, that means what? 10 to the power 4.
Yes.
So
That's 10,000.
you get 15, 10 to the power 4 will be 10,000, right?
Mhm.
Okay, and silver plus or minus 10% silver. And this one here, okay, you can get 15 times that number and 10 to the kilo ohm. Okay. Basically, you can get 15, 0, 0, 0 plus 10%. This is 3 0 here.
Kilo.
3 or 4.
Should be 40.
4 0. Okay. So that means yellow multiplied by 10 power 4. Okay. 10 power 4 need one more 0. So that's why you can convert into 150K. K means 1,000.
Okay, so on the top, you got right there, you got 15 times, look like 100,000. That should be 10,000, not 100,000.
10,000.
Yeah, 15 times 10,000. So there should be 40. You got 5 zeros on top. Okay, right there. Okay. And the bottom, so you multiply that until it gives you 150,000. Okay, so
Okay.
that looks good.
That's correct. Okay, that's what I want you. If you're able to do that, assembler job technician, we don't need that. We're using the meter. Okay, conductance. Basically, conductance, they use just basically opposite to the resistance. Okay, conductance, they allow more current flowing. Resistor opposite to the current flowing. So G equals 1 over R. And the unit will be Siemens. Okay, where R is the resistance. Unit will be in ohm. Like they given you 5 ohm, they want to know the conductance. Or they given you 100 kilo ohm. They want conductance. You do it by yourself. Now, that is the main thing we have to understand. You understand the relation between the voltage, the current, and the resistor. That's what they're talking about on law. Okay? Normally, E means the voltage equal I times R. In this formula, E must be in volt, I must be in ampere, R must be in ohm. And from this formula, you're able to calculate I equal E divided R, or R equal E divided to I. That's what they're talking about Ohm's law. Okay? And now, if you see this circuitry here, E the voltage here, I is the current, R is resistor. If you want to calculate I, you take E divide R. Okay? So whatever you want to calculate it, then you're using either this formula or this formula or this formula. Now, the lamp, this is the lamp right here. Draw 25 milliamp. When connect to a 6-volt battery, is it resistance? So they're looking for resistance. You're using R equal E divided to I. E 6 volt, that's okay. I 25 milliamp. You must be converting to the amp. Okay? 25 times 10 minus 3. They have to be in amp. So you can take a 6 divide to 25 and 10. If you don't know, I can give it to you. Okay, 6 divide to 25. 6 divide 25. You get 0.24 times 10 minus 3. When you bring it up, then will be 10 power 3. Okay, that means 0.25 times 1,000. you get 240 ohm. That's a very, very basic, okay? If you get any question, bring it up.
So did you say you had to convert is it milliamps to amps?
That's what they asking for. They already telling you right here. In this formula, A voltage must be volt, I must be ampere, I must be in ohm. If it's not, then you have to change it to exactly the unit. If they give a kilo ohm, you have to multiply by 1,000. 10 to the power of 3. If they give a current in milliampere, you have to convert it into the ampere.
Okay.
Okay? They both be. So,
Question,
yeah, go ahead.
on the go up, it says -3. Here you said it's +3.
When you bring it up,
Here, yeah, that's correct.
you want to bring that up to here.
Because there's no negative, right?
Yeah.
Yeah.
When you bring it down, negative.
Okay, thank you.
You're welcome. Okay, now this is just giving you a more formula. Okay, you want to calculate the power. You understand it when you turn on the headlight of your car. Okay, basically the current goes through resistance inside the bulb. If you touch it in the front of the light, you feel hot. What happened? Basically, it's converting electrical into the heat. Okay, that's why you can see it warm, a little hot. That's what they call power dissipation. Okay, through the resistor. And the formula to calculate the power dissipation. Okay, P equal I square times R. In this formula, P must be in watt. I must be in ampere. I must be, you can see you go to the bottom line bulb. You can see 50 watt, 100 watt, 150 watt, depending on how the line working. And also, you can calculate the formula power, okay, by P equal V square over R, or P equal V times I. So in order to calculation, okay, of the power, to get 3 formula. P equal V times I, or I square times R, or V square over R. However, either formula, unit power will be watt, V will be voltage, I will be ampere, I have to be in ohm. That's just the formula, depending on when you do the calculation, what they given to you. Okay, now you get 2 different type of the circuitry. One they call a series circuit. Okay, another one will be parallel circuit. So try to make sure you're reading current is the same everywhere in the circuit for the series. The total resistance equals the sum of individual resistance. Total voltage equals the sum of the IR voltage drop across individual resistance. That means inside you get the two resistor, okay? Then each resistor will be dropped how many volt. When you're adding up, they have supposed to be equal the power supply, okay? Total power is equal to the sum of the power dissipated by each resistance. Okay, so that's a very basic thing you must know and have to remember for the series circuit. Okay, when you're looking into the circuitry here, I know they will be series. How do I know? You get 24 volt here, and you get the current. You see that? Current flow. So current will be the same on R1, the same on R2, and the same on R3. So I know they will be a series. When the current go to resistor different, they will be in parallel. In order to recognize, okay, series or parallel, that's what I'm telling you. If the resistor get the same current, they in series. That's the first thing. The second thing you see, this is what is it here?
Common ground.
Normally we call a common, right? Or round. Okay, that's a common circuit, common for the whole circuitry. Or normally we call it round. In this circuitry, you get R1, R2, R3, three resistors. And I'm telling you, you get A here, B here, and that will be C and D. We don't care. Okay, so first thing, nothing to talking about the current I. There's only one current flowing. Okay, however, I want to emphasize here, the voltage across R1. Okay, let's see, the voltage across R1. Then normally you can say VR1. VR1 means the voltage across this resistor. And if you're looking on the schematic, they will be equal VA minus VB. That means VA minus VB. And that normally I can say VAB. VAB means VA minus VB. That only telling you the voltage at A will be higher than the voltage at B. The thing is when current goes to resistor, they turn out to be the heat. So the voltage will be wrong. Same thing. When I say VR2, that means VB minus VC or VBC. And the last one R3, VR3. That will be VC minus VD. And VD is common. Okay, so they will be the same as VC. Now we can go through here. Current is the same through each resistor. Voltage across each resistor is different. VR1 is not the same VR2, not the same VR3. The thing is you understand that you want to calculate the voltage V equal R times I. You get the I the same. However, R different. So that's telling you the voltage different. Okay. Power dissipated by each resistor also is different. Okay, total resistance. So if they're asking a total resistance for series circuitry, adding on of resistor for this one, R1 plus R2 plus R3, L plus Rn, doesn't matter how many resistors you get in series, add them up. If you want to calculate the voltage across resistor R1, okay, I already telling you here. VR1 equal VA to B equal VA minus VB equal I times R1. The same for VR2 and VR3. And now, after your calculation, if it's okay, then the total voltage must be equal the total drop across each resistor. Okay. If you want to calculate the power for R1, PR1 will be I square times R1. For R2, I square times R2. Okay. And R3, I square times R3. Also, total power will be E times I. And that must be equal total power to each resistor. PR1 plus PR2 plus PR3. Okay. So now you quickly given to me the answer for 1, 2, 3, 4, 5, 6, 7, 8. I try to get the right answer. Okay. For some students still a little slower. They're able to follow it. Do it for me. Total resistance.
12 ohms.
6, 10 is 12 ohm, right?
Yes.
Okay, good. Quickly. Current.
24 over 12. 2 amperes. 2
Total
amperes.
current.
2 amperes.
2. Voltage VR1.
4 volts.
4 volts. VR2.
12.
12 volts. VR3.
8.
Perfect. Power. VR1.
8 watts.
VR2.
24 watts.
VR3.
16.
So that is on the answer. For this circuitry, I hope everyone get the same.
One question.
Yeah, go ahead.
So I understand now how you got all the answers, but where did you get the 2 amps from? I'm trying to figure out from the diagram.
You mean what on number? Number 1 or 2?
Number
3,
2.
4. Which one?
Number 2.
Okay, they want to calculate the current. And you know is I equal V divided to R total.
Okay, so with that formula, and we just plug in the voltage for
24. R total, you get 12.
mhm.
The thing I might try to make it clear on this example, and you can see around, okay? Very, very basic thing.
Yeah, so it's just 24 divided by 12, which gives you 2 amps, is that correct?
Yeah, 24 divided by 12.
Okay. Yeah, it's okay.
Mr. Fan, can you use microphones for background noise, please?
I try, but the thing is, I cannot get the muse. Okay, here, hopefully. Just a minute.
Sound like somebody's typing while you're talking.
Right, I know. Just a minute, I try to mute.
I got a question on number 2. How did you get the 12 on the R?
How come they cannot mute? Just a minute. Mute on. But they're not.
Whoever's typing, if you can mute yourself.
See, man. How come? I cannot get to the mute.
Mr. Gual, his icons.
Okay, let's see. I can look here to see who not mute. That's okay now. Mute. I see everything here is mute.
Yeah, it's Booker. Booker, can you mute yourself?
Here. Okay, here.
Okay.
Better now.
So who get the question? Let me know.
I
Go ahead.
have a question. I was trying to submit my assignment and I didn't do it properly. So how do I catch up? I mean, I got the letters onto the grades onto the paper, and then onto the computer, and I was on my cell phone. I was trying to submit it. So I missed those steps by you yesterday. How can I go about correcting them?
Okay, now. Any question regarding into that display? I can answer you. You can get a question about assignment. Will be talk to you later.
Okay.
Okay? That will be confusing. Okay, so that is a calculation and also the answer. Anyone get a question regarding into for the DC series circuitry? Okay? If it's not, go. Now, you get a voltage divider. Voltage divider law. That means another way to calculate the voltage. Okay? Let's see what they say. They say apply to the series circuitry only. To calculate the voltage from a B here. Okay? To round here. Same as the voltage across R2. That means the voltage from B to round same as the voltage here. Okay, we can calculate the current I, then VR2 will be equal I times R2. That's what you get normally. However, they say we can using voltage divider. So VR2, you take the E here, times R2. Divide R1 plus R2. Okay, that you can get the same answer. You see that? Instead, you have to calculate the current. You don't need it. You can calculate the voltage across that resistor here by voltage divider law. Try to say how much you understand. For this circuitry here, R1, R2, R3, R4, they want the voltage at point B here. Normally you're doing, you have to get the total resistance, adding that one, that one, that one, that one. And then you can get the current, take the E, divide to total resistance. That's what you get the current. So if the voltage from B here, then you have to get the voltage drop here, adding voltage drop R3, adding voltage drop R4. However, they want to using the voltage divider. So now who can tell me voltage divider at B equal what? First thing you say E, right? Time what?
R2 times R2.
If you time R2, that not mean from here to round. Voltage from B to round will be a voltage drop across R2, R3, R4. So they will be multiplied by what? I'm telling you. R2, R3, R4. Divide total resistance. Okay, that's a voltage divider law. So now I want VS as voltage C, VC. Using voltage divider. Then you still get A time what?
R3 plus R4 divided by the total resistance.
Okay, that means multiply by R3 plus R4 and divide by total R1, R2, R3, R4. Okay, and the last one will be SA right here. A time what?
R4 divided by the total resistance.
Perfect. Okay, basically, you can do by either way. You can calculate the total resistance. Then you calculate the current. Okay, then if you want to calculate the voltage. Now, when they say VB, what that mean? VB, that means only single point. Normally, you measure the voltage, you need the high side and the low side on your meter. So when they say only VB, then the high side have to be connected to B. But the low side, you cannot connect to C. You must be connected to common to the ground. You have to understand that. Now, if they say, I want to measure VR2, then the high side of the meter connect to B, and the low side connect to C. Across R2, you can see there's a big difference. When they want to measure only single point, A or B or C or D, whatever, then the other side of your meter must be go to the common. Okay, any question about voltage divider? Okay, let's see. I try to get, let's see, this one 25 here. Okay. I want at pay. Okay, now you see on this circuitry here. Okay, calculate telling me. What VA equal? Who get the answer?
Five volt.
5 volt.
Yes, sir.
Correct. Now, I'm telling you, VA, okay, you see that the power, positive connect at this point, where the negative? Where the negative for the 10 volt
Ground.
ground. That's what you need to know. When they put only positive here, you must understand the negative of the power supply connect to ground. So basically, they will look like that one. Plus 10. And that one will be ground. And you're using the voltage divider. VA equal 10 times this resistor 50. Divide 50 plus 50. That's what you get. 5 volt. Okay, now try to me that one, 20 volt. Okay. Point A, point B. I want VA and I want VB. Do that calculation. Make sure you understand. If you know the voltage divider, then you understand they will be a 20 volt time R1 10 no time 10. Okay. Sorry. Okay, A mean time R2. Plus R3. Divide R1, R2, R3. Okay, if they want B, 20 times R3. Divide R1, R2. That is how do we calculate it. If you get a question, just let me know. I don't care about the answer. But if I given you the way we're doing calculation using the voltage divider. No question, right? If it's not, go to next. Now you get the second one, parallel circuit. What they talking about parallel circuitry? They telling you voltage is the same across each branch of the circuitry. The total current equal to the sum of the individual branch current. The equivalent resistance are equivalent is less than the smaller branch resistance. Total power equal to the sum of the power dissipated by each resistor. Okay, now you see you get this circuitry here. You get R1, R2, R3, or Rn, no matter how many more resistors. Okay, so when I'm looking into the circuitry, they will be in parallel connection. How come? The thing is, you can say you can get the total current flowing from the power E, go to here. One go to R1, and one go to R2, and one go to Rn. Okay? They're not the same current. They get a different current. Okay? So, however, the voltage across R1 VR1 or VR2 or VRN the same with E right here. So that's why they say E equal VR1 equal VR2 equal VRN. And the total current IT here will be I1 plus I2 plus what? How many more branch current? Okay. Now, total resistance. What they mean about total resistance? Normally, you get this circuitry. They want to convert it into the circuitry. Only one source and only one resistor. That still be E. However, they are equivalent. You see that? The thing is, the Ohm law will be applied into this circuitry. So first thing, you need to calculate the R equivalent or total resistance. In order to do it, this is the formula given to you. R total or R equivalent. So that will be the same as R total. Will be equal 1 over R1 plus 1 over R2 and plus 1 over Rn, no matter how many more resistors. That's what they calculate the total of the equivalent resistance. So when you get the total resistance, easy for you to calculate the current flow in here, I total. You take E divided by R equivalent, Ohm law. That's what you get the total. Now, the voltage will be the same. VR1, VR2, VRN the same. If I want to calculate the I1, how? Who tell me? What I1 equal? You can using law. The voltage across R1 here mean E. So that E divide to the R1. You get I1. You want calculate I2, the same thing. E divide to R2. Or Rn, you get the E divide to Rn. That's what you get a current. That's more easier. Okay? Now, in here, they given you parallel circuitry R1, R2, R3. They want to get the R total or R equivalent. You doing calculation telling me, is it you get 3 ohm or not? I want to verify that answer is right or wrong. To do it, R total equal 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so try to work it out. Next Monday, we'll finish for the DC. And on Tuesday, we'll start with the electronic. Now I have to stop my lecture for Sam to run the quiz. Okay, I will be stopped my share. Okay, Sam.
Okay, yes, sir. One moment. Let me go ahead and set it up.
Make sure they download, right?
Yes. So let me go ahead and share the screen. Okay. Share. Okay, so make sure you go to the, just go to a website. So what you want to do is go into a website. So the student asked earlier for Tech 1 and Tech 2. This, you always come into a website. You just have to do it, just scroll down here. If you need to find the assignment, it's listed here. It's all listed. Here's Tech 1 for the semester. Here's Tech 2 for student who's in Tech 2. These are assignment for Tech 2 student. For Tech 1, these are the assignment. Okay, so that's where you can find all your assignment. All right, so make sure that you go in here, you go to click on handouts menu, and then you come down here and click on this one, said eQuiz 01 Spring 2022 report. You click on that to open it up. So you're going to be using that to put all your answer on. And then you're going to have to upload this onto the website after the after you complete it. Okay, so enable, and then click on enable editing to enable editing, and I got extra messages. So this is the answer sheet. So it's going to be 18 questions. So you're going to put all your answer here, either A, B, C, or D, whatever it is for each one of this. Okay, so make sure you put your name on top here. And then when I run the test, you put your answer here. So you're gonna be, this is how the protocol gonna go through for the rest throughout the semester. Okay. All right. So so is everybody already got downloaded the answer sheet for the quiz?
Okay, if it's not, they can
Do it later.
write down in the paper and download later to
Yeah.
fill it in.
Okay, so here we go. We're gonna get going. Okay. Start from beginning.
How much time?
You got 3 minutes. Yeah, 3 minutes. So that means a minute per question. And then you got trying to do as best as you can. And then I think Mr. Pham going to upload this video onto the website. So this quiz will be due tomorrow by 12 noon. So therefore you have plenty of time to go. If you have to need more time, you can go watch the video and then just do that. And then just do it by watching the video. Okay, so that's pretty much the end of the quiz. So let me go ahead and end the slideshow. Let me see what's coming up on the chat. Let me stop sharing first. Let me see what's on the chat. Okay, so let me see. Okay, then where do we get this quiz? Okay, okay, so the quiz, you mainly get it from it's a handout from the website, and you don't get the actual quiz, but you do get the answer sheet from the website. Okay, so you go to the website. So you're going to a website here, and then you want to do is click on, say, handouts. You click on that, and then the answer sheet that you're going to put all your answers on is on this one right here. So you click on that. So, and click that to open it up. Okay, so open it up and click on enable editing. Okay, and close that. And when you come in here, you want to do is make sure you come in here and just put your name on here first. Okay, and then you go through, and then you're going to put your answers on this here from number 1 to 18, and then make sure you save this. Make sure you save this file, and then later on you're going to have to upload it to the website. So you're going to the website, same thing. You once you have ready, when you're ready to upload, you come into the website, click on the you come into the menu heading called upload file, click on that. And you come in here, same thing, you put your name on, first name, last name, choose a file, and then choose whatever file that the quiz that you just save on your drive, and you click on upload, and then it will go onto the website. Okay, let me see who's next on the chat. Let me read the next one. Okay, where do I get to go? The handout section, you type your answer. Okay, suggestion, talk to Mr. Pham about that was speed. All right. Okay. Okay, thank you, Lo. We'll do. Let me go ahead and take that for my own self so I can have some information to go by later. Okay, so okay, so anything else? Look like everything looks pretty good. Everybody, is it possible for you to show number 1 to 3 again? You will have opportunity, and it will be when you go into the okay, let me share screen. Okay, Mr. Pham will be uploading the video onto the video menu right under here. It will be the number 2 here. He will be uploading this video onto the website, and then you click on that, and you can go through the test, through the quiz, and you can speed it up or slow it down, or to go to any other question that you need to look at. Okay, let me go ahead and show you number 1 to 3 real quick. Okay, 1 to 3, show current. Okay. So that's question number 1, 2, and 3.
He's gonna put that on the web tonight, correct?
That's Mr. Pham hasn't control over that. I do not know.
Mr. Pham, you gonna put that on the web tonight?
Yes, sir.
Okay, thank you. I just missed the last one only, that's all.
Okay. So
Basically, for the student coming from last semester or before. So basically, I don't care much. Only thing is if you can do and get an A, that means you really understand it. Okay, that's just a review. And for the new student, that just show you the way the program running. We given you assignment, given you the quiz to make sure you're able to get it done. And the last one will be the final test. If you can do it and get the rate A or B or C, you'll be okay. More learning will be given you
Could somebody
very good knowledge.
bullshit on these things, and everybody is not a teacher.
Okay, so any more question, anything else? Otherwise,
Mr. Pham, once again, you're gonna put the video on tonight, right, on the web?
that's what I said. Yes, sir.
Okay, thank you, thank you.
Okay. Anyone not quite follow it, you can open the video and go to the test, giving you more time to do it. Okay. So,
Thank you. It's a great class.
okay, good
Thank
night.
you.
Okay.
Good night, good night,
Thank you,
good night,
Jose.
good night, good night.
Good night.
Thank you. Good
Okay.
night.
Tomorrow, take one, the new student, we get a different Zoom. On the other student, they want to go into that, okay to me. You don't have to. Okay? They just try to review and try to have the student install MCM7 lab and how to do it. That's a really good simulation lab program. Okay? So good night, everyone.
Good night.
Thank you.
Good night. Thanks.
Right.
Thanks. Bye. Good night. Thanks.